Here we are going to be looking at solving radical equations. So, say we want to solve this equation here, square root of x minus 2 equals 5. Our first step is to get the radical by itself. Hey, it's already by itself. I've got square root of junk equals a number. That's my first goal. Now I want to make this square root disappear. Well, what's the opposite of square rooting something? Squaring something. So we're going to square both sides. Squaring the left side, square root of junk squared is just junk. Square the right side, square root of 5 is 25. So we get x minus 2 equals 25. Add the 2 over, we get x equals 27. In these kinds of equations, you absolutely must check your answer every single time. It's possible that you'll get a solution that will work at some intermediate step but won't work in the original. So you must check your solution in the original. So if we plug in x equals 27, we get 27 minus 2 is 25. Square root of 25 is 5. It works out. So our procedure: get the radical by itself, raise both sides of the equation to whatever power you need to get rid of the radical. If it's a square root, square both sides. If it's a cube root, cube both sides, and so forth. Sometimes you'll have 2 or more radicals in your equation. You'll have to repeat this entire process. At the end, once you do all this, once you get rid of the radicals, you'll have either a linear or a quadratic equation, both of which you know how to solve. So you solve them, and then you check all your solutions. Okay, here's another example. We want to solve this equation here. First thing I have to do is isolate the radical. I have to get this square root of x plus 3 by itself. So I have to make this plus 6 disappear. Subtract it from both sides to get square root of x plus 3 equals negative 4. I want to make the square root disappear now. Notice here that I didn't square both sides to begin with. I got the radical by itself first. Now I'm going to square both sides. Squared the left side. Square root of junk squared is just junk. When I square the left side, I just get x plus 3. When I square the right side, negative 4 squared, I get 16. Subtract the 3 over, we get x equals 13. And we're not done. We have to check that in the original equation. It'll work fine here. If I go right here, yeah, works perfectly fine. Don't care. Have to check it in the original. So we plug in 13. We get square root of 13 plus 3, which is square root of 16. That's 4. Plus 6. 4 plus 6 is 10. That's not 2. We get this answer and it doesn't work. Now in this particular case, we could have noticed that right here in this step. We've got square root of junk equals a negative. Square root will never equal a negative. We could have stopped right here. Square root of stuff equals negative. You're done. Not possible. No solution. Not all problems will be that obvious, though. You always have to go back and check your answer in the original. Okay, so we only got one answer. It was x equals 13. It didn't work. We call that an extraneous solution. We throw that answer away. Since that was the only solution we got, and it was no good, this equation has no solution. Doesn't matter what you plug in here, there's no solution. Okay, let's do a more complicated example. Say we want to solve this equation here. Okay, so first thing we do, get the radical by itself. We're done. It's already by itself. Now we square both sides. Squaring the left side, square root of junk squared is just junk. On the right side, square x plus 4. X plus 4 squared, that does not mean x squared plus 16. Squaring something means multiplying it by itself. You have to FOIL that out. Check those details on your own. You get x squared plus 8x plus 16. This is a quadratic equation. We've got an x squared here. So now we have to get everything to one side. We could either factor, square root property, possibly, won't work in this case. Completing the square, quadratic formula. We know 4 methods for solving quadratics. I guarantee you any problem somebody would give you in a college algebra course, you're going to be able to factor. So let's get everything to one side. So subtract the x over, subtract the 10 over. We get this quadratic in standard form with a 0 on one side. That factors, which it always will. If you get a quadratic, it's going to factor. That factors x plus 1, x plus 6. We get 2 solutions, x equals -1 and x equals -6. In these scenarios, what usually happens is one works and one doesn't, but there's no guarantee. They might both work, they might neither work. You have to check both solutions if you get 2. So if we plug in x equals -1 into the original, -1 plus 10 is 9. Square root of 9 is 3. On the other side, -1 plus 4, 3. Everything works out. If we try -6, -6 plus 10 is 4. Square root of 4 is 2. On the right side, -6 plus 4 would be -2. Square root of 4 is not -2. That solution is no good. We call that an extraneous solution. So we only get one good solution, x equals -1. Okay, now the worst problem ever. These really are my least favorite problems in all of mathematics. I'm not going to lie to you and tell you it's fun. These are not fun. A lot of work. Okay, we're going to solve this nasty looking thing. First thing we do is get one of the radicals. I have 2 radicals. Get one by itself. Doesn't matter which one. It really doesn't. I chose to get this radical by itself. So I move the other one to the other side. Now we're going to square both sides. I want this radical over the 3x plus 1 to go away. So square both sides. On the left, square root of junk squared is just junk. On the left, I just get 3x plus 1. On the right, I have to square this binomial. That means multiply it by itself. And I have to FOIL that out. So 1 times 1 is 1. 1 times root x plus 8 is root x plus 8. For the inners, root x plus 8 times 1 is root x plus 8. And for the last, root x plus 8 times root x plus 8 is root x plus 8 quantity squared. The square and the square root just cancel out. We just get x plus 8. Stare at that. Make sure that makes sense. Root junk times root junk is just junk. Okay, we've got some like terms here we can add together. So the 1 plus the 8 is 9. We've got this x hanging out. He doesn't have a buddy. Then this radical, those are like terms. I have 2 of those. Okay. So I went through a lot of work and it looks like things got worse, but they didn't. They did get better. I started with 2 radicals. Now I only have 1 radical. I'm halfway done. That's only the first half of the problem. Now I have to make this second radical go away. So I have to get everything to the other side, isolate this radical, get it by itself. Okay. So moving everything else to the left side. Now I have the radical by itself, and you might be thinking, well, what about the 2? That 2 is multiplying the radical. I could do it either way. I could divide out the 2, or I could leave it here, and then when I square, just make sure to square the 2. I'm not too worried about this 2. It's stuff that's added or subtracted I really need to get rid of. Okay, now that I've got the radical, along with his buddy 2, isolated, I square both sides. So on the left side, I'm going to have to FOIL again. 2x minus 8 squared means multiply it by itself. On the right, Squaring this quantity here, I get 2 squared, which is 4. And root x plus 8 squared is just x plus 8. Okay, on the left side, we're going to have to FOIL here. We get 4x squared. For the outers, minus 16x. For the inners, another minus 16x. And then for the last, plus 64. On the right, just recopied it over 4 times x plus 8. This is a quadratic equation. We know 4 methods for solving those. All of them that are relevant here involved getting the equation in standard form. Get everything to one side and a 0 on the other side. Okay, so we have to clean up, distribute this 4, get 4x plus 32, and move everything to the left side. So you can check the details here. This is the equation we get. Notice that in this particular case, this won't usually happen, but here 4 goes into all of my coefficients, so I could just divide through by 4 and turn that equation here. Divide through by 4, we'll get 1x squared minus 7x plus 8 equals 0. Hey, that's going to factor. Imagine if you had to use quadratic formula now, after doing all that. Nobody's going to do that to you. And any problem you would get in a college algebra course, if you get a quadratic, it will factor. If it doesn't, you've done something wrong. This does factor. X minus 1, x minus 8 equals 0. We get 2 solutions, x equals 1 and x equals 8. We must check these in the original equation. They both work here. They both work perfectly fine. Both solutions work here and here and here and here. They may even both work here. They may even both work here. We have to go all the way up to the original to check the solutions. Okay, so you should write this down and check these solutions yourself. I've checked them here, and you can see that when x equals 1, it does not work. Square root of 4 minus square root of 9 is not 1. So this should say x equals 1 doesn't work. X equals 8, however, does work. We get root 25 minus root 16, which is 1. We get one solution. That's what usually happens, not always, but usually. You get 2 solutions, one works and one doesn't. Sometimes both work, sometimes neither. In this case, we only got one. It's x equals 8. Okay, that is solving radical equations. It takes some practice. It's messy. A lot of places you can make a simple mistake, but it's not too hard.